So let us recap on what we have discussed till now. We started our discussion with the history of power system network. We saw how the power system network evolved, what were the challenges in the adoption of AC, the fight between AC and DC systems, and then finally how the AC system won and the further evolution of power system network happened based on AC transmission. Then we also discussed the power system automation, how the relays were developed, how the power system automation applications were developed, how the SCADA was developed and utilized in the power system monitoring and control. Then we discussed the evolution of computer network, starting with the 1980s, where the local area network was developed. And then we also discussed the new IT related applications which are developed in recent past that were based on cloud solution, big data, and so on. Then we discussed the evolution of Smart Grid and Energy Independence and Security Act. So, Energy Independence and Security Act, that is ESA 2007, was implemented in US in January 2008, and that ESA 2007 Act gave the word called Smart Grid. Then we discussed the existing structure of power system. We discussed how hierarchically the power is being transferred from generating stations to the load end. Then we discussed the SCADA system, how a SCADA system is utilized for monitoring and control of the power system network. We also discussed the various challenges being faced by the SCADA system. Then we discussed the role of NLDC, RLDC, and SLDC, that is National Load Dispatch Center, Regional Load Dispatch Center, and State Load Dispatch Centers. We also discussed the energy management system application, how the data flows from SCADA to EMS, what are the various components of energy management system applications, what are the use of those components in monitoring and control of the power system network. Then we discussed the IT and OT, that is the difference between information technology and the operations technology, and what are the various challenges in the adoption of IT and OT convergence, and what are the benefits we will get when we merge IT and OT. Then we discussed the various smart grid definitions. What are the various definitions given by various agencies like NIST and IEEE? We also discussed the limitation of the definition and the missing component in that definition, which was given by IEEE. Then we discussed the need for a smart grid, why we need a smart grid now, what are the challenges in the existing power system network, and how the smart grid is solving those challenges. We discussed the smart grid network and what are the various smart grid building blocks. We also discussed various features which differentiate the conventional grid with smart grid, and what are the various characteristics which clearly differentiate the conventional power system network with the smart grid. Then we discussed the various smart grid domains as suggested by NIST, that is smart transmission, distribution, consumer, generation, service provider, market, and operations. So those smarter domains are part of the further journey of our smart grid technology in this course. Then we discuss various regulatory challenges the various regulatory agencies are facing in the implementation of smart grid technology and how it can be addressed. And then we discuss what are the various smart grid agencies which are working on the various smart grid technology and the various smart grid frameworks in India as well as worldwide. So this is what we discussed till now in our introductory sessions. From next video onwards, we will start our discussion on the smart grid architecture. We will try to understand how the layered architecture of the smart grid has been visualized, what is the role of individual layer, and why it is important to have that kind of architecture to be implemented for the realization of various power system activities.